pleasant greetings to all from Easy BTech. I'm Dr. Gayatri. I'll be taking you all with the topic on Planck's radiation law. From the topic of quantum mechanics, Planck's radiation law is one of the important topic. Generally, we have this topic to be completely with the mathematical derivation, and you can have a full score marks to be obtained being a mathematical derivation, and it is a very simple and interesting topic. So let's all join with AZBTech to learn the topic Planck's radiation law. As we all know, Planck, he was one of the important scientists in quantum theory or quantum mechanics who has postulated a law that emission or absorption of energy generally takes place in the form of quanta. Emission or absorption of energy takes place in the form of quanta. Here, the same scientist, Max, he postulated that electromagnetic energy is emitted. We are saying electromagnetic energy. This energy is emitted in discrete amounts. I say here, energy emission happens in discrete amounts. It is not in the form of continuous packets, but in discrete amounts. And these discrete portions are represented with h mu, where h stands for Planck's constant and mu stands for frequency of radiation. H is a Planck's constant and mu is a frequency radiation. Now, according to this Planck's radiation law, we have here the expression for energy E lambda d lambda. I'm saying expression for energy in terms of wavelength. We can give it either in terms of wavelength or the frequency. So here I'm writing for your wavelength. It is written as 8 pi hc by lambda bar 5 into 1 by exponential hc by lambda kt minus 1 into d lambda. When we are considering the energy in the range of wavelength lambda and d lambda. Here when I use here d lambda, it simply means that it is a very small wavelength region. The wavelength region is very small. Lambda and the lambda plus d lambda. So if I say that here I have 5 Armstrong units, it will be some 5.1 Armstrong units here. 5 plus 0.1. So within this wavelength region, we are having the energy of the radiation to be expressed as 8 pi hc by lambda bar 5 into 1 by exponential hc by lambda kt minus 1. To arrive at this expression, we are going to use this Planck's law. As I said, emission or absorption of energy is in the discrete packets, which is given by h mu here. So as I said, we have h to be called as the Planck's constant and mu to be called as the frequency of radiation, which have their general meanings. So in the generalized form, that is for n oscillations that we are having, it is E equal to nh mu, where n represents 0, 1, 2, 3, etc. The number. Now here, if you are saying that capital N is representing for you total number of oscillators. If I say total number of oscillators, certainly I'll be having individual oscillators to be present with me. So I'm going to call them as N0, N1, N2, etc. So if I add these individual oscillators, then I'll be arriving at my capital N, the total value of oscillators, the number capital N. Now each one, suppose N naught oscillators are there, they are having carrying energy of E naught. If I look for N1, these number of oscillators are carrying energy E1. These oscillators are carrying energy E2. So then what will happen for my total energy? It will be the summation of N naught E naught plus N1 E1 E2, N2 E2, N3 E3, so on. So capital E, the total energy is given as N naught E naught plus N1 E1 plus N2 E2 plus so on. I can take up to NRER. So when I'm writing the expression here, as I said, E naught is representing the energy possessed by N naught oscillators, E1 with N1. Here I'm using here 1, 2, 3. They are nothing but your integers. Having your energy, E1 has h mu, E2 has 2h mu. If I go for the next one, E3, 3h mu, E4, 4h mu, etc. That would be the energy possessed by each oscillator there. But according to Maxwell-Boltzmann distribution law, I have the expression NR equal to N naught exponential minus R E by KT. I'm saying this is according to Maxwell-Boltzmann distribution. This is NR equal to. If I want for the complete individual to be given, I can write here N naught means R equal to 0. N1 means R equal to 1. N2 means R equal to 2 and so on. So this implies that my N value to be written as N naught plus, if I take with R equal to 1, this expression here R equal to 1, this becomes N naught exponential minus E by KT. Now if I take with your N2, it becomes N naught exponential minus 2E by KT. If I take with the 3, it becomes N naught exponential minus 3E by KT. So on up to some R value. This is what you can observe. Now, if you look at this here, N naught plus N naught E bar minus etc. What is common for us? N naught. Take N naught as common, then it becomes 1 plus exponential minus E by KT exponential minus 2E by KT exponential minus 3E by KT and so on. From this expression, what can we recall? What is that you can recall from this particular expression? It is of the form 1 by 1 minus x. If you can recall from your mathematics, that is simply is giving you the expansion of 1 by 1 minus x. That is simply if you have 1 by 1 minus x, this will be written as 1 plus x square plus x cube plus so on. The same thing here you are having where your x is representing e power minus e by kt. So if you are using that particular mathematical formula here, this becomes n naught by 1 minus exponential minus e by kt. So this is your capital N value. This is your capital N value. Now we will look for your capital E, the energy possessed by the oscillator. So when I look for the term of energy, you are having N naught, E naught, N1, E1. When E1 is represented as I said, you can have it to be H mu, or I can simply say that E. E2 when I have, it is 2H mu, or I can simply say 2E. So the same I am going to represent here, capital E equal to N naught, E naught plus N1, E1 plus N2 E2. E2 means as I said it is 2E into N2. If I go for the next one it is E3. So I will write it as 3E into N3 plus so on. But we know the values for your N0, N1, N2, N3 etc. And also we are having here your E values. So substitute them. You are having N0 value as N0 and your E0 as 0. And when I go for the next one, it is N1 into. So using your Maxwell's distribution law, this formula, I have your N1 to be written as N0 exponential minus E by kt. This is followed with E1, where E1 is represented with your energy as E. Next, I have your E2, wherein I can use here your 2E and I can multiply it by N2, which is written as N0 exponential minus 2E by kt. Similarly, if I go for the third one, 3E into N0 exponential minus 3E by kt plus so on. So I have this part to be given now. So if you look at this expression, you have few terms to be common. Take out all those common terms, but this value is 0. You can just look, the first one is 0. So from the second one, you have the values. What are the common terms that we have? N naught exponential minus E by kt. This is your common term. Then what is left for you? 1 plus, I have even E also to be common, so I'm taking that also out. 2 exponential minus E by kt, because I already have exponential minus E by kt to be outside. So how much will be left out of minus 2E? Minus E is taken out. So it will be with exponential minus E by kt. The second one becomes 3e power minus E by kt. So it is also once again your generalized expression from your binomial expansions 1 by 1 minus x whole square, wherein I can have it to be 1 plus x plus 2x squared plus 3x cube plus so on to be answered. So I'm having here 2. So now I'm having this expression to be rewritten as exponential minus e by kt into 1 by 1 minus e power minus e by kt whole square. 1 minus x whole square, no? So I'm having it as 1 by 1 minus x whole square. This is giving me the total energy possessed by the harmonic oscillators. Now, how do we give average energy? This average energy is given by E by N. I'm saying average energy. So average means total energy by number of oscillators. Since I'm talking in terms of energy, energy by N. Capital E by N. Capital E is calculated and we are also having your N value in the previous expression here to be obtained. So now use both the substitutions here to get the value of average energy. So I'm substituting those two expressions here. So look at your N and E value. So I have N naught e power minus E by kt with exponential into E divided by 1 minus e power minus E by kt whole square. This is only energy. What is your N value? N naught by. But here your N is in the denominator. N is in the denominator. So it becomes reciprocal there. So I'll write it as 1 minus e power minus E by kt divided by N naught. So now we can have a simplification to be done here. N naught, this whole square. So what will be left for us? E into exponential minus E by kt divided by you can take your exponential minus E by kt as common from the numerator. Then your expression becomes E by exponential E by kt minus 1. Since from the denominator e power minus E by kt is taken common, then your numerator and denominator will be cancelled and you will be left with this particular expression, E into. Now, what is your E? As I said, it is your h mu. So I can write it as e power h mu by kt minus 1. This is your average energy. So what will happen for your number of oscillators in the frequency range now? What will happen for your capital N? Actually, it is generally given by 8 pi mu squared by c cube into d mu. Okay. So now total energy per unit volume. Within the frequency range of mu and mu plus d mu, I can write this as E mu d mu equal to, because I will have it to be 8 pi mu squared by c cube, which represents me with my n value into average energy. What is your average energy? This is your average energy. This will be present value. It's nothing but multiply this, you will be simply getting it as c cube exponential h mu by kt minus 1 into d mu. This is in terms of frequency. If we want to have it in terms of wavelength, we will simply use mu is equal to c by lambda, or I can say d mu is equal to minus c by lambda square into d lambda. If I substitute that, we will have your final expression which is there in terms of wavelength. So in terms of wavelength, this could be written as E lambda d lambda equal to 8 pi hc by lambda power 5 into 1 by exponential hc by lambda kt minus 1 into d lambda. This is the energy in the range lambda and lambda plus d lambda. Hope it is clear for you all. You can have this derivation to be represented for Planck's radiation law. Thank you. Like, share, and subscribe for applied physics classes through Easy BTech. Thank you.